Yo, I've been thinking about this architecture problem all day. Come here, let me just show you. Think about this for a moment. This code passed code review, 3 senior developers approved it, and it's been in production, serving real customers. But it almost took down a Black Friday. Not because of a bug, not because of a performance issue. The code works, but the architecture doesn't. Here's the code. Tell me if it looks familiar to you. We have one handler function, about 170 lines of code, and it does everything. Up here, we have the database queries to get product prices, discount calculations, and tax logic. In the middle, we have Stripe payment processing. On the bottom, we are saving things to the database and sending confirmation emails. So if we look at this, we have business logic, infrastructure, third-party APIs, all in the same function mixed together. And if you're being fair, the code is fine. It works and it handles errors properly. We have 3 senior developers that approve this PR, for example, and I would too. That's the trap, because it's not about whether the code works today. It's about what happens when you actually try to extend it. Let's look at this. Week 1. Feature ships, everyone is happy, PR is approved, the tasks pass, production is stable, and the team feels very fast. And they are fast. This is real, like it's working. Fast forward to week 3. Now, a new requirement pops up. Now we have to show product prices in the cart endpoint. A developer needs product prices, right? He opens up the order handler, sees the query, copy-paste it into a new handler, and it's done. Fastest way to meet the deadline. There's small duplication in there, but it seems fine for now because there's a little change needed for this. Fast forward, week 5. Someone notices the duplication and creates a helper function. It's a good instinct, right? The order handler still has the same inline version as before. The cart handler still has the copy-paste version, and only the new code is actually using the helper. Now, we have 3 ways to get product prices in the same code base. Fast forward, week 7. Remember, we didn't refactor things before. We didn't agree completely in what approach was ideal. So fast forward now, 3 developers, 3 different approaches. One returned just the price, another returns an object, a third one returns a dictionary. No agreed pattern so far. Everyone solving the same problem, just in a slightly different way. Week 10, circular imports starts forming. Orders depend on products. Products depends on discounts. Discounts depends on orders for loyalty discounts. Everything depends on everything. At this point, you can't test anything in isolation. You can't change one single thing without breaking another. Month 6. Here's where things get real. The test suite takes 45 minutes to run now. Nobody runs it anymore. Production bugs are weekly. Simple changes take days because everyone's scared of breaking something in the code. The developer who wrote that first handler we talked about, the one who shipped on time, passed code review and got the thumbs up, they are looking at this and thinking, how did we get here? This is insane. I did everything right. And here's a sentence I've heard multiple times in past companies. We're talking about a rewrite. 6 months, working code, senior developers, good intentions, and you're talking about a rewrite? So here's a very important thing that people miss. Every code base has an architecture. If you didn't choose one, you got one anyway, by accident. That handler I showed you in the beginning, that is architecture. It's just not the one anybody decided on. It's the one that happened accidentally. It's the one that happened when nobody made a choice. And accidental architecture always ends the same way. Now, here's where everything gets really worse. Because everything I just described, that timeline assumed humans were writing the code at human speed. Now, you let your team code with AI and you don't just get the same problems, you get them 10, 100 times faster. Think about this. You ask AI, add a loyalty point discount feature. AI looks at your code base. It's gonna see different patterns for handling discounts. It's gonna pick one. Maybe it can create a 5th one. We don't know. It generates code following that pattern. Now, you have 5 patterns. The AI didn't fix anything, it just copied the mess that was in the code already. AI doesn't fix architecture, it just amplifies whatever exists. So the thing is, if you get a good architecture in place, AI is going to follow the patterns and you're going to get consistent results with a lot more speed. But if you don't have any architecture, AI is going to copy the chaos. You're going to get spaghetti 10 times faster now. So we're basically diving into a world where we're getting exponential amount of spaghetti code because everything is written by AI and it's based on whatever architecture is in place. If you had a good structure in place, you have a chance that the AI is going to make the right choice. So if you're planning to use AI, and you should be, you need a better architecture. So what can we actually do about it? Let me take you to that first handler we talked before, and let me show you one decision that's going to change everything. You don't need to rewrite it. You have to pull it apart. So let's look at this. Step one, we're going to take the business logic out. We have the discount rules, we have tax calculations, order totals. That's your business logic. It doesn't need to know about any HTTP handling. It doesn't need to know about Stripe. It doesn't need to know about your database specifically. It's just math. Step two, we take the infrastructure out. We take the payment processing out. We take the database. We take email handling. Those tools, they serve the business logic, but they shouldn't read from it. On step three, what's left? It's the glue, right? Your handler, it receives a request and it passes along. That's all it should do. Now, look at what we've got. That's exactly our architecture. And here's the thing I want to be very clear about. I'm not telling you that you have to architect everything before writing a single line of code. That first handler, ship it. Get it done, pass code reviews and make it work. But somewhere between that first handler and the moment your code base actually starts growing, before that copy paste starts, before developers create 3 different patterns, make a decision. Because the window to make that decision closes very, very fast. Week 1, it's a 2-hour refactor. On month 6, it's a rewrite. And the only difference is when you choose to think about this structure. Debugging a discount bug, that's one file. Like 20 lines of code or so. It's pure math. It's easy. A new developer joins, they know the structure of the code base. It's obvious. They can look at the structure and see where things belong together. The tests, they run in like a millisecond. They're going to be so fast because they don't depend on everything. If you want to test one single behavior of your code base, you can do so. You don't need to build up the entire application. And now, the more interesting, AI-generated code, now it generates a clear separation of concerns because it can follow the existing patterns. It can follow the architecture that you set up in place from the beginning. Think about this. If you already have a clear structure about how you want things to connect and belong together, you can actually write all those rules also into the agents.md file. If you do that, it's going to be very easy and obvious for the AI to write things in the right places. So here's what I want you to do this week. Ask your team, where does new code go for this domain feature? If nobody has a clear answer, that's your window. It's probably still open. 2, pick one piece of business logic buried in the handler, extract it into pure functions, no dependencies, try to put things apart like that and see how feasible that is, how glued your architecture is already, and if it's possible to do that. If you're not able to separate things out easily, maybe you're already entering in that chaos architecture problem. 3, next time someone opens a PR with copy and paste logic, don't just approve it. Take the moment to ask that person, hey, let's actually reserve a little bit more time to refactor this area and pull it out. Now, I'm not going to pretend that there's no cost in it. Your first feature and the reveals and even the asks that we just mentioned about, they're definitely going to take a bit longer. But you're thinking about structure, you're defining boundaries, you're creating the structure so that when you get to the future, you're prepared for this. And here's the thing that doesn't show up in sprint metrics, but everyone feels: developer confidence. When your code has clear boundaries, you're not scared to make any changes. You run your tests, they pass in seconds. You deploy, there's no sweating. There's no, let me deeply check if that payment processing still works. That feeling, that's what architecture brings you. It's not just speed, it's actually confidence. And we can only get real speed when we get a lot of confidence in our code. That's the confidence that the next Black Friday issue won't be yours. And before I go, a quick gut check. How many of these sound like your code base right now? We're talking about a rewrite. I don't know which version of that function is the right one to use. The new developer asked about a code that nobody had an answer. If any of this hit, you don't have technical debt. You have architectural problem. Now you know what to do about it. I wrote the full blog post walking through the code examples, and the link is in the description. There's also a GitHub repo with all the code examples we walked through here. If you want to see a more practical side, how to actually refactor things into a clear architecture step by step, that's the next video. See you in the next one.